It's fast. It's a lot for people to show up after work. But just going to give you a little brief intro on us. We're dfwmobile.net.
And the clicker should be hooked up.
Here's our Twitter handle and our website if you want to find out more information about us. This is our leadership group. All four of us are here today, so everybody pitches in a lot to help out the group. And we want to thank Matrix, which is a resourcing establishment, but they provide the office or the room. They provide food and drink, so it's always grateful to have a sponsor. So today our speaker is Michael L. Perry. Really doesn't need much of an introduction. He's very, very well known within the community. He's the mathematician of software engineering. He's got a lot of Pluralsight courses on just patterns and cryptography. You can also find out more information about him at Q.E.D.code.com, or you can go to his Twitter handle at Michael Perry. And today he's going to be talking about, I kind of messed up there, but he's going to be talking about three-way data binding using XAML and universal apps, using XAML, using view models, the view, and the cloud. So I'm just going to give you a heads up. Our next meeting is going to be moved up by a week on March the 5th. The speaker is going to be James Montemagno, Xamarin's own evangelist. So he's going to be coming by. He's going to be talking about automating UI tests and monitoring mobile apps, which is an interesting topic. As a matter of fact, later on that week, he's going to be speaking at MVP Mix. If you guys are familiar with that, it used to be Dallas Days of .NET. They changed it up. If you guys are interested in that, you guys can look that up. Google that organization. Get a couple of tickets to it. Check it out. So, without further ado, Michael.
All right. Thank you very much. And so hopefully this doesn't swap things around too much, and yeah, it kicks me out of the Hangout. So if you are in PowerPoint, then Google crashes. Okay, you hold on. Let's get back into the Hangout. All right, so now we should have everything good. So we're back on Hangout. The audio is good. Okay. All right, so yeah, as Homero said, we're going to be talking about three-way data binding, the view model, and the cloud. So the last time I gave this presentation, I asked people to come up here and role play these different parts, and turns out that wasn't really a good thing to do in a room full of introverts. So instead, I will actually be showing, not people doing these things, but actual code doing these things, and I will still ask for your participation in the form of questions and challenging anything that that you see. Question it, make sure that I'm explaining it well, make sure that I got it right. And so for really good questions, I give out Pluralsight subscription cards. So each one of these cards is good for 1 month of training on Pluralsight. All you can watch for an entire month.
I have a question. Can I have a call?
No, you have to ask a good question. But I'm sure that you can come up with one.
All right,
It's not that difficult. So this is also going to be within the scope of universal applications. So universal really means universal for Windows, not universal as in all platforms. But within that context, universal applications are how we, going forward, are going to be building Windows apps for all the different form factors. Microsoft has shown us that with Windows 10, we're getting convergence of all the different platforms coming to one version of Windows, and so universal apps are how they want us to start to target those. So right now, universal apps will help you target a desktop or tablet scenario and a phone scenario. But you can fully expect that more of these device categories are going to be coming online with universal. And so I'll be showing you this demo within that scope of universal apps. But let's first of all get started with what does this three-way data binding thing mean. So how many people are familiar with two-way data binding? All right, awesome. Everybody? Excellent. So with two-way data binding, you've got your view and your view model. And your view would have things like a text block where you've got binding that points to a property inside of the view model. And so whenever that property changes, you have to fire property changed. Tell everybody that things have changed. And then when it does, the view updates. But the challenge comes when you've got two different views that you want to keep in sync. So one of these views, it's saying hello, and so it's bound to the greeting. And it's a text block, so it's just going to display that greeting. But with the other one, we've got an edit view. And so with the edit view, you can change the person's name. So this one, we've got a binding through a text box. So you enter somebody's name, it raises property changed, and what we want to happen is that this greeting says hello and then this person's name. So we want these two things to be in sync. So what are some of the mechanisms we can use to keep two view models in sync? Anyone used anything like in MVVM Lite, for example? Well, you've already seen this. But a message queue, yes. If you were to put a message queue or a message bus down here, then this view model could publish a message to this message bus. The other one could subscribe to it. And so whenever this property changes, in addition to raising property changed, it also publishes that message. That one picks it up, and it makes the appropriate change with that. So so this is the typical style of getting multiple views through multiple view models to work in sync. But now, what I want to challenge you with is that maybe this isn't the best way to go about that. Maybe instead, if we had a common place to put shared information, we wouldn't have to publish something to a bus and make two different copies of the information. So here the name ends up in this property and it ends up in that property, and you've got two copies. So this kind of brings me back to what is MVVM in the first place? Well, so far we've had our view and we've had our view model. MVVM stands for model view model. So where's the actual model in this picture? There's nothing there for me to put my data into if I'm just keeping it in the view model. So what we can do is introduce this shared model that now both of these view models can get their data from. And if we do this, then we don't need a message bus. So this edit view, you enter something into the text box. It's going to set the property. And all it's doing here, you can see, is it's passing that down to the name property of the person. So we're setting it there. And now this view model is returning hello plus the name of the person. So it's getting the name from here. We're not storing anything in either of these two view models. we're only storing it in the shared model. And so this is the core of what we mean by three-way data binding, is that we're not just data binding the view to the view model, but there's also a model that's participating in the data binding. Something else you can kind of see from here, this text block is read-only, therefore this property only has a getter. In MVVM with raising property changed and message buses, you have to have a setter here as well, but now we just have a getter. We're just getting a property, and we're projecting it up from the person up in through the view model to the view. But now looking at this, what problems do you see? What challenges are going to make this difficult to make work?
Where you're instantiating person.
Right, where we're instantiating person? Yeah, that's not represented in here, but yes, something outside needs to instantiate a person and then inject it into those two. So we'll have some dependency injection going on in order to solve that problem. But there's something else that's missing here that we saw in the previous slide. You got it, Bill.
The race changes.
That's worth a Pluralsight card. Yes, sir.
Is it for me?
Yes. Yeah, so what's missing is raising the property change. So how is this ever going to work? Well, let me show you how that might work. Not that one. That one. Okay. So here we've got our person model, and you can see it's got a name property. And then I can read that name here inside of my hello view model. You can see our dependency injection going on here. Somebody else is creating the person and injecting it into this view model. And we're just saying hello and displaying that name. And then, in addition to that, we also have the edit view model, which is getting and setting that name. Now, to kind of complete this picture, the thing that's doing this dependency injection is our view model locator. And so here, the view model locator is creating a person, initializing it with some design mode data because we just want to be able to see something in the designer, and then giving us an edit view model and a hello view model. And then if I look at that inside of the designer, open that up, then up comes, what's your name? Sean, and hello, Sean. So, looks like it's working. Let's go ahead and give it a shot and see if we're running into any difficulties. So, I'll change this to Michael. And no, it still says hello, Sean. So, exactly, it didn't raise property changed when I changed that property. So by inputting here, I have set the property in the model, but now the view model doesn't actually know that it changed. So there's one more piece that we need in order to get this three-way data binding to work. And that is a piece provided by a little open source project that I created called Assisticant. And if you go to NuGet, you can see you can just add Assisticant to your project. So what Assisticant will do is, first of all, you go into your model, and now instead of just a string for the name, I'm going to make this an observable string. So we'll bring in Assisticant to help us with that, and initialize it there. And then this is name.value, so we're getting the value out of that observable. So observable is just something that will hold on to that string or int or whatever else, whatever other type you give it. It'll just hold on to a value. But it's also helping out with the data binding. There has to be something on the other end of this in order to finish it off. And we put that in the viewModel locator. So we'll use the viewModel locator base class. And now here, instead of simply returning the viewModel directly, I'm going to call the viewModel method and pass in a lambda. And this returns an object. But that's okay, we don't actually need the real data type in order to do the data binding. And so now, let me just double check that I didn't make a mistake that I commonly do. Yeah, okay, so it is doing two-way binding there. I often leave out this two-way here, and so it just binds toward the user but never back. So yeah, it is doing two-way binding. But now that it's going down through the observable, let's see what happens. I change this to Michael. And it changes to hello Michael up there. So what we've done is we have marked all of our model properties with observable. And that means whenever they change, it's figuring out what view models depend upon it and making them raise property change. And it's doing all that through the view model locator is what's wrapping up that view model in order to give it that capability. So that's one of the core components of three-way data binding is that we need something like Assisticant that will help us with that dependency tracking and figuring out how to raise property changed. Yes, sir?
So, I'm not familiar with WPM with SAML, and I thought this thing come out of the box of the SAML, and that's the beauty of WPM, because in like the web application, you have to use like knockout to do that. Mm-hmm. But I thought this has always been out of the box. It's not.
Yeah, what comes out of the box, and that's worth a Pluralsight card. What comes out of the box is the ability to use the iNotify property changed interface and to explicitly raise property changed when the value changes. So what we're doing now is we're not explicitly raising property changed, and in fact just letting Assisticant figure out when it should be raised. And the reason that we don't want to take on that responsibility of raising it ourselves is because we aren't data binding to the model. We're data binding to the view model. And that's a very astute observation about knockout, because when you're talking about dependency tracking, that's exactly what knockout does. It does the same sort of dependency tracking that Assisticant does, where, and that's exactly why you have observables in knockout, for the same reason as you do in Assisticant. So what dependency tracking is actually doing is whenever I read a property of my view model, it's going to put something on a stack and say, okay, I know that you're reading the greeting property. And now I'll let that code run. It'll come over here into the model, and it'll say, what's your name? And so that'll read the value from the observable. So the observable sees something is reading my value. Oh, that's the thing on the stack, the greeting property. Therefore, I know greeting depends upon name. So through that read process, through getting the property, it figures out what the dependencies are. And then when you change the property, then it says, okay, the name has changed. Therefore, my dependent greeting has changed. Hey, view model, raise property changed. So that's what's happening under the covers in order to make all this work. And that's the core of three-way data binding.
Are there any, like I know with Knockout, there was some performance issues with it. Like if you were attaching it to a lot of objects to observe, with this, is it more performant, or is there anything to worry about? Should we approach the same way we approach Knockout?
Yeah. So so would there be any performance problems? And are you already a subscriber?
Yes, I'm already.
Yeah. Okay. So this is a classic time versus space trade-off, where in order to keep track of everything that's happening, it does take some space. So so if you have a large number of objects, then you are allocating a large amount of space. There are two core differences, though, between the Assisticant implementation and the Knockout implementation. First of all, Assisticant is in C#, and Knockout is in JavaScript. And as much as JavaScript has been optimized, it still is a bit more of a memory hog than C#. And its garbage collector is not quite as effective. So so even though you are still taking up memory for each binding, it's less of a burden in a managed language like C# with a good memory manager than it is in JavaScript. But the second thing is that Assisticant will hold off on all of the raise property changed until you're completely done changing your model. Knockout doesn't do that. So with Knockout, as soon as you change something, it updates the DOM. But that's because JavaScript within the browser doesn't have this idea of idle time. And idle time has been something that's been built into Windows since the very beginning. You've got all of your events that are happening, and then it goes idle. And so it waits until it goes idle in order to update things. That way you don't get event storms. Yeah. So, all right, I can hear myself just fine. Right, great questions. Okay. So, so now we want to talk about not just binding between two views on the same device, but now let's talk about binding between two views on different devices. So for that, we'll review something called the CAP theorem. So who's heard of the CAP theorem before?
Heard of it.
One. Yes. Well, you've probably been to one of my talks where I talk about the CAP theorem. This is one of my favorite theorems. And if you don't know me, it actually does make sense for me to say I've got a favorite theorem. So the CAP theorem says that if I've got three different promises that I can make about distributed systems, and those are CAP, then I can only ever uphold two at any given time. So those promises are consistency, availability, and partition tolerance. So consistency is saying that if I've got two different nodes within my distributed system, and I write from one of those nodes and then read from the other one, then I will get back a version of the data that's at least as new as what I just wrote. It might be newer, but it won't be older. And then availability means that when I talk to one of these nodes, it's going to respond in a reasonable amount of time and not just give me an error. And then partition tolerance says that it's going to uphold whatever other promises, even if there's a network partition and these two can't communicate with each other. So intuitively, it's pretty obvious that if I'm trying to write to something and there's a network partition, I can't expect it to return what I just wrote. The information can't get over there. So it either has to give me an old bit of information, in which case it's not consistent, or it has to give me an error message, or simply wait, in which case it's not being available. So the CAP theorem says we can only have two of those three promises. Now, in a mobile application, the node in the distributed system is the phone or the tablet that's in the user's hand. And it's very likely that that partition between that node and other nodes within that distributed system is going to be interrupted. So partition tolerance is non-negotiable. I have to have partition tolerance in a distributed system. And then furthermore, when somebody is using their phone, they don't want to just see an error message. Oh, I can't connect right now. Sorry, I can't help you. And they don't want the phone to sit there and wait until it can reestablish a connection. They just want it to respond to them. So responsive design actually used to mean something different than it does now. It means that it actually responds. So in order to get something that's responsive, it has to be available. So availability in a mobile application, non-negotiable. Which means consistency is negotiable. It has to be. So in a mobile application, if you're going to be working offline, you're going to be inconsistent. You're not going to have the latest data. And your users have to be okay with that. And your application has to be okay with that. But inconsistent, meaning that I've written one version and I read a different version, is not the same thing as a conflict. So first of all, we've got this idea of eventually consistent. If I just wait long enough, then instead of the old version, I will eventually see the new version. So that's an important promise. People want to see that. And we get that through queuing. I'm going to put something in a queue, and then it'll eventually be delivered. So I queue it up on my device when I'm offline, so it'll be delivered to the server. I queue it up on the server so that when my device comes back online, it gets the latest information. And so we're going to see how we can achieve the promises that we need through queuing in the rest of this presentation. But all of that is not the same thing as having a conflict. And a conflict is what occurs when one user writes one version and then a different user writes a different version of the same document. And now, which one is right? So it's possible to be in a conflict situation but still be eventually consistent. Here's how. I've written one version, and then some point later, I read and I see, oh, it could have been the triangle or it could have been the square. And my friend eventually will see, oh, okay, could have been the triangle, could have been the square. So eventually, they will see the same thing. But it's this set of possibilities that they eventually see.
One user gets disconnected.
Right, perfect example. So if one user gets disconnected, so in this case, let's suppose that this user is connected. So he pushes his triangle up, server sees it, triangle's good. This user is disconnected, he creates his square, but he can't push it to the server. He thinks square is the right answer. When he reconnects, then that's his first opportunity to send the square to the server and his first opportunity to receive the triangle from the server. So in order for us to remain consistent, they both have to eventually get the same answer to the question of what shape is it. And so if they both get back the set, then they're still consistent. And so in that case, we have been available in the disconnected state, but then regained consistency when you reconnect. Let me... what is the difference between consistency and correctness? That is a deep question. Well, I would say that consistency is it's simply two different parts of the system having the same answer. That's really all the consistency is. It doesn't say whether it's the correct answer or not. So if we were to replace this with circle on both of these sides, okay. You know, if I notice a conflict and then I just send down a circle, well, it's obviously incorrect, but it's the same answer, so it's consistent. If you have a system that always says 0, what is 5 plus 7? 0. It's consistent. It's just not correct. Yeah, so I would say then correctness really has to do with what the app is supposed to do, and so partition tolerance and availability also factor into correctness. It is correct for the application to still respond to the user while it's disconnected. So that's, yeah, I think that's where I'd draw the line between them.
Question?
Yes.
I'm not getting the picture because, I mean, this one's sending a triangle, this one is sending a square, but the server, let's say, is sending the square and the triangle. Is the server deciding what's correct or just sending out whatever it received?
The server is just sending out what it received in this case. Yeah. Let me show you an example, and that should make it a bit more clear. So this is an application called Cardboard, because with this app you get to move cards around on a board like kind of like Kanban. And so I've got Cardboard running on both of my Surfi. So with this one, I should be able to say I want to add a new card, and I will call it hello. And when I hit OK, then it adds it to the board, and it also sends it to my collaborators. So then I can pick it up, move it, and it moves on somebody else's device. Or I move it here, and it also gets pushed to this device eventually. There we go. So, so we've got a collaborative application where both of them are online, and so somebody's able to collaborate with somebody else, moving their Kanban cards across the board. But now, what if somebody goes offline? So I'm going to go to Settings, and Networks. Hello. I want to disconnect from the, there we go. Okay. Turn on airplane mode. So now I am disconnected from the network. So I can move this card to the doing column, and I see that it's in the doing column, but my collaborator doesn't see that change.
So why don't you take the hello on that one?
Okay. So now I've got one change here and a different change there. So if I go back online, so turn off airplane mode. Now, it might take a little bit of time for it to notice. Oh, no, it didn't take too long at all. Yes, now we see that the card could be in either one of those two columns. And I kind of grayed it out so that we can tell. I'm not sure, but here's what it could be. So now, there's a conflict. The user can see that there's a conflict, but it's consistent. Both of the users see the same conflict. And so now, as a user, I can simply pick up one of the cards, move it, and the conflict is resolved.
So what if you moved it underneath?
Oh, yeah.
You dropped it on the other card. Was that?
Yeah.
Or
No, underneath would have done the same thing, because these are just lists. And so if I drop it anywhere on the list, it'll...
say, for example, a person put it to the doing
Mhm.
is the boss, and the person that put it to do was co-worker.
Mhm.
Do you have any sort of notions of rules
Who wins? Conflict resolution. Yeah. Not in this app, but that is up to your app to decide what does conflict resolution mean for you. In this app, All it's doing is showing you that there's a conflict and giving you a chance to resolve it. But what we're going to go through now are the set of patterns that allow you to detect and resolve conflicts. So you don't have to show the conflict to the user if you can figure out a good resolution yourself. So let's see what those look like. Okay, so the core of this idea is that what we sometimes think of as state isn't actually state. If I'm playing chess with somebody, then the position of the pieces on the chessboard look like state, and I can move those pieces. So it looks like state can change. Well, in fact, a chess game is not a board position. It is a series of moves. And so the board position is really just a projection. What has occurred? What is the state of the system after I've made all those moves? So if I want to play chess by post with somebody, we don't box up the chessboard and FedEx it to our friend. No, we just write a letter with one move, and they append that to their history, and then they figure out what the board position looks like by making that move on their board. So we can exchange these moves instead of exchanging the output state. And things get a lot easier when we do that. Primarily because the moves are immutable. Once I make a move, I can't take it back. I can't change it. That is the move. But the board position is mutable. And you can't sync two things that can change because they can change in one way on one machine and in a different way on another machine. But you can sync things that are immutable. An immutable thing is simply a fact. That this was the move, that's a fact. You can't dispute that. I'm just sharing that information with you. What you do with that information, that's up to you, and that's where we get into the conflict detection and conflict resolution. So what we're going to do is instead of capturing chess moves, we're going to capture other decisions that were made, but this time by a user of our application. So the user can decide that they're going to create a card. So we'll capture that as a card created fact. And we'll give that card created fact an ID. So we just know that there exists a card with this ID somewhere in the system. And so far, that's all we know about it. Then we can also say, okay, after I've created the card, I want to put some text on it. So card text changed. So that would be what text we want to change that card to. Oh, and it would also have to have the card ID so that it could identify that card's text has changed to this. We could also decide that we want to move a card. So let's capture a fact that says that I've moved a card from this column to that column. And then at some point, we want to take it off the board, so we'll record a card deleted fact. And so we've got all these decisions that the user is making, and then we capture that decision as a fact. And now these are just the pieces of information that we need to capture in order to understand completely what that fact means. So let's first group these facts according to the objects that they affect. So some of them affect the board. Which of these facts affect the board?
What do you mean by board?
Okay, yeah, good question, good question. So, so now I'm thinking in an object-oriented world where you've got a board which has a list of cards. So that list of cards is a property of the board. And if I want the board and that list of cards to be a projection of what has happened, then a couple of these are going to alter that list. So we've got.
Except the text change, I guess, affects the board.
Well, actually, it's just the card created and card deleted because that's when I'll add and remove from that list. Ah, yes. Yeah, sorry. Forgot to clarify there.
So move's not affecting the board.
Right. We're going to consider the column to be just a property of the card. So yeah. So there, in that case, these two affect the card. So now we've grouped them by the objects that they affect. And so now you can see, well, okay, since these two affect the card, we are just going to kind of assume that the card ID is part of those facts. Which card do you affect? Bless you. So then there's one other thing, and that is that when I change the text of the card, then just like we saw with card moved, we could get into a conflict situation where one person has changed the text to one thing, and then somebody else has changed it to something else. What I'm going to do is capture that this card text is changed from this to this. So this card text is changed, and I know what the previous state was. So I'm keeping track of that prior fact. And if I do the same thing with card moved, now I no longer need to know the column it was moved from, so I can kind of drop that. The card was moved to a particular column. If I need to know what column it was moved from, I just look back in history and say, oh, that's the column it used to be in. So the way that we use that to detect conflicts is that when the card is created, we're going to create a card moved fact right off the bat that says the card has been moved to the to-do column. And so that way when the card first appears to the user, it's in that column. And now one user picks it up and moves it to doing. So they're going to create a card moved fact to doing, and they know that the card used to be in to do. But then somebody else, disconnected, only knows this fact. And then they move to done.
But in this diagram, we're not showing the temporal information.
That's true.
It looks much more like a class diagram.
Yeah, in this diagram, we're not showing the temporal information, as in we don't know which one of these two happened first. But we are showing this predecessor relationship. So yeah, it looks like a class diagram. Actually, this line means that this one happened before that one. So this one is a predecessor, that one's a successor. And so given that information, it is somewhat temporal. I just know that this happened before this one, but it's not fully temporal. I don't know which of these two happened first. And that's the difference between a total order, or a full order, and a partial order. So with a full ordering of events, I would know precisely this one happened first, then that one, then that one, then that one. In a partial ordering, I only know that some things happened earlier, other things I'm not certain about. Yes?
I think also the app we're designing isn't so much concerned about time in some connections as in what the transition was. You know, we're not going to use absolute time as the resolution mechanism.
I understand.
Yes.
It was just that the diagram was somewhat ambiguous as to what was being talked about.
Yeah. I didn't clarify that the arrow meant the predecessor. Right. Yeah, good point. Yeah, so with partial ordering, we can look at this as a tree and say, okay, how many leaves are in this tree? Well, I see 2 leaves. Therefore, there's a conflict. And these leaves represent the candidates, the possible outcomes of that conflict. If somebody were to take that card and move it to a particular column, then they'll create another card moved fact, which will say that the card has been moved to done with the knowledge of these 2 predecessors, that I know that it used to be in both to do and doing. So now if you query this tree, you find that there's only 1 leaf. 1 leaf means no conflicts. So it really does come down to just that. Can we look at a tree and count the leaves? And that's the crux of how we're going to do conflict detection and conflict resolution. And now we mix that in with the dependency tracking, and now we've got 3-way data binding, not just to a shared model on the device, but now across devices. shared data binding to the cloud. Beautiful stuff. So, so now this is what I call a historical model, where we are capturing a history of events, or I like to call them facts, because events confuses people with event sourcing, and event sourcing is based on total ordering of events. Historical modeling is based on partial ordering. And so in order to capture that partial ordering, we've got these references where a card moved fact knows about prior card moved facts. And it could be 0 if it's the first one, it could be 1 if there was no conflict to begin with, or it could be 2 or more if it's resolving a conflict. And then these board facts, so card created, card deleted, they don't know about any prior facts. But these know about the board that they affect, these know about the card that they affect. And so, yeah, we're not ready to talk about that guy yet. He's kind of cool. How are we doing on time? 7:30? Okay. All right. So, another question? Okay, so I'm just pulling up some code on the tablet here so I can cheat, because y'all don't want to see me fumbling through this. Oh, well, that'll be a good timer. When we run out of charge, we're done. Okay, so so here is our cardboard application, and I'm going to test drive our way into this this implementation of capturing events and keeping track of what the current candidate is. So if I take a look at my tests right now, I will see that only one of my tests is currently passing. Oh, and by the way, for how many people have used test-driven development? So yeah, if you okay, awesome. Right, yeah, this is not the right way to do test-driven development. That I did want to point that out. Test-driven development doesn't mean write all your tests and then make them pass. It just makes for a nice, easy video if you don't have to see me, or our demo, if you don't have to see me write the tests before I write the code. So I've already got all the tests written. I just need to write the code to make them pass. Yeah, I have a friend who thought that test-driven development meant write all your tests first, and he tried it and is like, no, this is stupid. Well, of course it's stupid. But I didn't understand why he was so against TDD for so long. I mean, it was years. And then I said, oh, no, don't do that. So, so yeah, don't do TDD this way. But for right now, the only test that's passing is that the application board cards count should be 0. So I should have no cards on my board. Is kind of the top of the object hierarchy. Not hierarchy as an inheritance, but application owns the board, and the board owns the cards. So we're saying, okay, we don't have any cards for right now. When I create a card, this is how I want it to be. I need to create that message that represents that fact, that the card has been created. And the thing that should do that is the thing that knows about card created facts, so the thing that knows how to handle them. So I'm going to ask the board to do that for me. So I need the board to create a card. And I want it to give me back a message. So the message data structure, remember, messages are immutable, just like those chess moves. Once I've created one, I can't change them. So all of the fields of the message are read-only. I can't change them once I've created the message. Furthermore, the predecessors, this list of pointers back to which messages came before, that's an immutable list. I can't change that set of predecessors. Once the message is created, that's it. But I'm not going to use this message constructor. That's private. Instead, I'm going to use something that's a little bit more friendly. Right here, we're going to create a message given a message type, a set of predecessors, an object ID, and a body. And this body is just going to be an anonymous object. So you'll notice some things here about these messages. I don't have a message base class from which you inherit different message types. The reason for that is that we've got different versions of our application over time. I want those different versions to be able to collaborate with each other. So if I'm still using an old version of an app and you upgrade and we're both working on the same board, you're going to be generating messages that I don't understand yet. I want to be able to take those messages in, store them on my device, and then when I upgrade, then I'll understand them. So maybe I give cards a color. And you say, okay, I've got color changed. Well, I still see all the cards as yellow. But then when I upgrade, I say, oh, wow, look at all these colors that you've created. I didn't notice that before. And so we want to be able to take this message type, not as a CLR class, but just as a string. And then take this body, not as a specific type of object, but just as an anonymous object. And then we're going to convert it into an expando object through JSON. And that way we can keep it as a dynamic. So you'll see up here, the body we're going to treat as dynamic. So that way we can go ahead and take on these messages before we fully understand them. And we'll be able to version over time. So let's go ahead and use that. So when I want to create a card, then what I'm going to do is return message dot create message, and then the message type will be card created, and then the object affected is the board. For right now, we'll just say GUID.empty represents the board, because right now we're not going to have multiple boards within our app. And then we're going to say I want a new anonymous and so the card created message is going to have a card ID, and that's going to be some GUID. So let's, oh, we've already got the GUID right there, card ID. So we've created our card created message right here inside of create card. But we're not actually applying that message. All this is a message factory. It's just saying, I'm a board, I understand card created messages. That responsibility is encapsulated within this class. So I'm just going to create one and give it back to you. So, oh, yeah. So that means, going back to my test, I'll run that test and it will still fail. But now it's going to fail for a different reason. There we go. One card created. It's failing because when I ask the application to handle that message, now it's saying, well, I don't know how to handle messages. So, so we're doing this test-driven, simplest thing first. We're going to say, okay, I know that the board can handle messages, so board, handle the message. And so let's go ahead and declare that method here. And so in comes this message, and I could run the app again, the test again, and it would fail right here because this is not implemented yet. And I would know, okay, for right now, the only message that could be coming in is card created. So let's just assume that that's what's happening. And what I want to do is get the card ID, and that's going to be inside of the message.body. And remember, that's dynamic. So now I can just access any of the properties of the message body and there was a property in there called card ID. The thing is, that is going to come in as a string, so I need to do a GUID.parse on that string, and now I've got my card ID, and I can say cards.add and do card with that card ID. So now when we run that test, that should work. Oh, and we're running out of time. Okay. Yeah, I do have a plug. Do we want to keep going? Okay. Oh, do we? Okay. All right. Yeah. Okay. So, so far we've just set up kind of the rudimentary ideas of we're going to route a message to the appropriate object. So in this case, we're routing the message from the application to the board, and then we're going to handle that message with the appropriate handler. So we dispatched it to simply creating a card, and so now we've got one card on our board. So let's just run all of our tests to see if accidentally we've made the other one fail or made any other tests pass. And we should see that we just have 2 passing right now. And of course right now, so no, we actually did make this one pass as well. So 2 cards created. Yeah, so if I create 2 cards, then I get 2. That's good, that makes sense. But now here, if a card is created twice, now there's an important feature of messages in a messaging system, such as this, that they should be idempotent. That if I see the same message twice, I only handle it once. So anyone familiar with REST, the 4 HTTP verbs? So among the 4 verbs, do you know which ones are considered idempotent? Idempotent? Post is not idempotent, actually. Post is really the only verb that is not idempotent. Sorry.
What I use the most. So.
Yeah, I know. Post has no promises. You post something, anything can happen. Get is safe because you can call get any number of times and it won't change anything on the server. Put is idempotent. You put once, it's going to make a change, but you put the same thing a second time, there should be no change. Delete, same thing. You delete something once, it's gone. Delete something again, should be okay, should be no change. And idempotency is really important in a distributed system because you're going to get errors. And the error might occur trying to send the message, or it might occur while you're trying to receive the response. You don't know which. So if you try to send and an error occurs, it doesn't get to the recipient, then you have to try again. But if it did get to the recipient and the error was on the way back, you don't know, and so you have to try again. And now the recipient has to understand that it might see the same message twice and only handle it once. And so that would be idempotency. So in this case, we are trying to add a card to the application twice. So we want this thing to handle this message 2 times. So what we're going to do is right here, we're first going to see if cards.any, and I have to do, yeah, you notice that I don't have any of my system.link extension methods, so I don't have my .any in here. Here's a nice little trick that I like to use. Rather than scroll up to the top and add using system.link, if you just type enumerable, that comes from system.link. So enumerable dot and then control dot, and now you can bring in using system.link and then delete it. That one's for free. So any cards, C, arrow, C dot card ID is equal to that guy. So actually, if we do not have any of those,
Your objects don't have to be dynamic, do they?
no, the objects do not have to be dynamic. The only thing that is dynamic in this system is the message body. Right. So now this is going ahead and parsing the GUID out of the message body. So that's the dynamic part. But now we're back into the real world of strong types. And now we're seeing, are there any cards with that card ID already? And if not, then I'll go ahead and add it. If so, do nothing. So that's an important part of idempotency. Receiving a message twice is not an error. You just do nothing. You just say, OK. Pretend as if it was the first time you saw it. Yes?
So if you were using the cloud, where would you be putting your, where would you send the message to the cloud?
Where would you send the message to the, are you already a subscriber? I think you are, but yeah, OK. If you're using the cloud, where would you send your messages? That is a component that I will typically call a distributor. Because you send messages to it, then it distributes out to all the mobile devices. We won't have time, obviously, in order to go through creating a distributor, but that will be in the course. That's actually the module I'm finishing up this weekend. So, a distributor could be something as simple as a oh goody, I get to update. A distributor could be something as simple as using an Azure table storage in order to just shove your messages into it, and Azure notification hubs. So if somebody's got their device online and a message comes in, use notification hubs to send them a push notification telling them that they've got a new message to pick up. And actually, that's exactly how I build the distributor in this course, and it is just dirt simple. So let's see if that is enough to get that test to pass. And we can see card created twice is the one that we're trying to fix right now. And for some reason, whenever doing demos, the unit test runner is extremely slow. And now it must be doubly slow because not only am I doing a demo, but they're doing demo. But okay, and so yeah, we've got it to pass. So now I create a card twice. It only actually creates the card once. So how about deleting a card? So here I'm handling the create card message, and now I need to handle the delete card message. So this is going to be very similar to that. It's just going to be card deleted with that card ID, and then I want to handle it. Before we go on to handling it, remember I was talking about event sourcing. Is anybody familiar with event sourcing? Has they done any? Okay. So in event sourcing, they like to use the idea of a command and an event as two separate things. So commands are things like delete card, create card. They're imperative phrases. Do this. Commands simply create messages. They don't actually do them. Card deleted, past tense, an event. So I still like to use the terminology of event sourcing, even if I don't call these events. I call them historical facts, but it's still imperative, past tense. So I want to delete the card. It creates the card deleted fact. And now when it comes back to me and I handle that message, now I have to know which kind it is. So first of all, let me extract this method out, and I will call this handle card created, because in addition to that, I want to have a handle card deleted. So that's going to parse the card ID out of the body, and then it's going to try to remove any cards with that ID. And now here we don't have to do anything. Remove all. Yeah, that's the version of it that takes the lambda. So now we don't have to be careful about it and check things, because we know that remove all, if there's nothing that matches that lambda, it's just not going to do anything. That's what we want, so we're good. But now the problem is, which one of these two do I call? Well, I could do that this way. You know, if message dot type equals card created, then call this. Otherwise, we handle card deleted. Okay, so if I do that, so card created and deleted, that should work. Running. And it does pass. So we are able to create the message, route it back through, handle the message, and it goes to handle card deleted. But over time, that's going to get really ugly, having all these if-else, all that stuff. So what I have done to emphasize my point is I've created a message dispatcher, and this is a dispatcher for the board. So new message dispatcher. Now I can say dot on. So when I see card created, then I want you to call this action. And this action is going to take a board and a message. And I want you to call board.handle card created with that message. And then do the same thing with card deleted, handle card deleted. So now instead of getting all this ugly code here, I can just simply say dispatcher.dispatch to this target, that message. So that just kind of takes care of the the message dispatching for me, figuring out, okay, when you see this type, send it to that method. So keeps it a little bit cleaner, and it still passes the test. So if you want to dive into the message dispatcher, it's pretty simple. Just a dictionary of strings to actions. So action is satisfied by a lambda. If you find the message, the handler for that message type, then you just call it with the target and the message. So just something to keep things clean. And so now we are seeing all of the board-oriented tests are passing. And then we need to move on to the cards and see how we're going to move cards from one column to another and set their text. And this is where we're going to get into all that predecessor stuff. Okay, so let's jump straight to card moved. Now that we've got kind of our framework for how we're going to handle messages. There we go. So you'll see I've got all this stuff commented out. And that's because right now it doesn't quite compile. Right now I have text and column just as straight properties of the card. And there's a problem with that. If I've got a conflict, how am I going to recognize that with just a string or just a column? Column, by the way, is an enumerable. It's just which of these three columns. There they are. Wow. Which of these three columns is the card in? So that's all that property is. So what do I need instead of these properties in order to find whether there's a conflict? Instead of a single valued property, card ID. I've already got the card ID as a property of this guy.
Message?
Oh, message. Yeah, getting closer. I need to know.
This column. The prior column.
Yeah, I'm going to use the prior column in order to figure it out, but when I'm looking at the specific state right now, I need to know all of the possible states that it could be in. So not just the one column, I need to know all of the columns, all the candidate columns. So instead of a single value property, I just need a list. So let's go with the column here, and we'll make this IEnumerable. And so rather than having this be just a little auto property, let's give it a backing store.
Everybody want to break in?
Okay, and so we'll just satisfy this with a list of columns, and now I can get that list of candidates. So the column could be any one of these, but as Bill was pointing out, you need a little bit more than that. You need the message. You need to identify. That was Sean. Okay. As Sean was pointing out, you need the message. You need to know how it got there. And so just column isn't quite enough. Let's call this candidate type. And if I spell it correctly, then I can bring it in. Here's what a candidate is. It's the value, and it's a hash of the message. So what do I mean by hash? I mean, why is that important? The previous, exactly. Let me show you. So who's, not Buck, the other shell. The Git shell. Who's familiar with Git? Okay. So got a lot of people that I can teach some Git real quick. Git is a revision control system that, oh, it's not a repository. Hello. Okay. So it's a revision control system that is based on a local repository. So it's solving exactly the same problem that we're trying to solve with our mobile apps. Is that I have a history of facts right here on this device that I can use, even when I'm disconnected. And so here's the Git repository for this application. And so you can see that I've got several different revisions that are happening throughout history. And so you can see it's all nice and clean and linear. But what happens if I check out, like I'm going to go back to the beginning of Module 1, and I'm going to create a branch. I'll call it test. And I've got some changes in here. Oh, yeah, I don't want to do that inside of this repository. Let me go to a different repository. I'll go to the Assisticant repository. Okay, this is clean. Actually, this probably already has some branches in it. Yeah, lots of branches. Okay, cool. So, so you can see that instead of just this linear history of all these commits, we've got parts where the commits branch and then they come back together. Linear history of commits, is that a full order or a partial order? That linear, that's a full order, exactly. That's a full order because I can tell for any given commit what came before and what came after. With these branches, did this commit come before or after that commit? Well, I don't know. There's no relationship between the two. It's just drawn before that one, but it could have been drawn up here after that one. It would have been just fine. It still means the same thing. So a Git repository is a historical model. It captures a partial order of historical facts, each one being a Git commit. And the way that it identifies these facts, these commits, is a SHA. A SHA is a cryptographic hash. Now, why it has to be cryptographic? Well, probably because there's less chance of a collision if it's a cryptographically strong hash. So that's probably why they chose it. It's not that you're actually digitally signing this saying this really came from me and I can prove it because I have the private key and here's my public key. It's not that kind of a hash, but this hash is probably unique within this this repository to that commit. Can't be guaranteed, but it's really close to probably unique. So so that's the SHA of that commit right there that we see at master. And then here I see the SHA of the parent. So I know that that commit came from this previous one. That's its predecessor. If I jump down here, I see a merge commit. So this is when I accepted a pull request. So somebody else made the pull request in their repository, so they created a commit. I already had my history. I took their pull request in by merging it, and now I've got this merge commit that has two parents. So I know that this commit has two predecessors. And I'm capturing that just by their hashes, just their SHAs. So I could tell before I did that merge that there was a conflict, that there were two branches of the code. And then the merge resolved the conflict and brought them together. And the way I did that is by capturing these hashes. And so that's exactly what we're going to do. Is that we are going to capture the message hash and the value as the candidate. So, so in the interest of time, I'm going to kind of jump ahead. That rather than keeping track of this as a simple list of candidate of column, I'm going to keep track of this as mutable column. So what does mutable do? Mutable gives me a list of candidates. It gives me a way to create a message. We'll get to that in a little bit. And then it gives me a way to handle a message. So when I handle a message, what I'm going to do is I'm going to look through my my list of predecessors. So these are all of the hashes that at some point in history came before this particular set of leaves. The candidates are the leaves themselves. So I'm going to look through that list of predecessors and add the if that set of predecessors does not yet contain this message hash. So I'm not seeing some old message come in. This is a brand new message. Then I'll go ahead and add it as a candidate. So okay, this is a possible value right here. But I may have some other candidates. And in fact, I may have some candidates that this one has as a predecessor. So they should no longer be candidates. And so now I will remove all the candidates where the this new set of predecessors contains that hash. So I take a new message, I add its hash to the predecessors, and then I add it to the candidates only if it's not already a predecessor. So,
a table hash? Or a hash table?
Yes, this is a hash table. Yes, so I am these hashes are SHA-256 hashes in this case, and the this list of predecessors is a hash set. So it's taking the integer hash of that hash in order to find out what bucket to put it in. But that's just a really fast data structure for keeping track of a bunch of predecessors that I don't care what order they came in. Yep. So using this, I'm able to compute on the fly the set of candidates. I see a new message, then I'll add it as a candidate, and I'll remove any other candidates that it refers to. And so now, when this new message comes in, I know what the possible state is. And so that brings me to creating the message in the first place. So when I create the message, I want its set of predecessors to be the hashes for my current candidates. So maybe there's a conflict. Maybe I've got two different candidates. It could be in the to-do column. It could be in the doing column. So those two candidates have different hashes that came from their messages. When I move it to the done column, that card moved message is going to have two predecessors. And so I just capture those. And now that is the message that resolves that conflict. Yeah.
How can you tell from the message hash? How can you tell which one is first and which one is second, or which one is which would come first? Because message hash is basically just series of there's no timestamp, right?
Exactly. So how can you tell which came first? If you have just a list of hashes, you can't tell. But that's okay. You don't need to tell. All of the candidates, everything that is in the possible current state, could have all happened at the same time. It doesn't matter the order in which they happen. What matters is the order in which their predecessors happen. So the only information you have is that when I see this message, I know that its predecessor came before it. So I know that this value is replacing that one.
So is this hash table just essentially each list within the hash table is on essentially at the end of this operation one element?
Yes. So if I'm hearing you correctly, then if for example I just have one user and he just moves the card again and again and again, you're going to have card moved, card moved, card moved. You're going to have a linear stream, and each one's going to have one predecessor. Right? Yes. So so then it's only when I've got two users and one of them's offline, it'll fork, and you'll have two messages with the same predecessor. And then when they resolve it, then so now you've got two candidates, but then when they resolve it, now that message has two predecessors, and so it brings back to one candidate.
So last in will resolve it.
Yeah, in that case, the last in would resolve it. Yeah. So, so you might be used to systems where the last one wins in the case of a conflict. So this acts a bit differently. So I made the decision to move this card with prior knowledge of where it was. You made a decision to move the card with that same prior knowledge. Now it doesn't matter which one of us wins, which one of us gets in there first, because we both have that same predecessor. And so it still ends up with two possible candidates. But then what happens later when now somebody makes a decision with the knowledge of that conflict? They know about both of those predecessors. That prior knowledge is captured as that list of hashes, and that's what is added to the system. So, yeah, a little bit different than the last one wins that you might be used to. So, let's real quick use mutable. So now instead of returning column, I have to return column.candidates, and now I've got the list of candidates. Everything should be building right now. And then I need to route the message to the card. So let's do this real quick. When we handle a message, I'm going to look for the card. And again, I need system.link. So I'm going to look for the card, where the card ID is equal to the message object ID. So if this message is affecting a card, then I'm going to get a card out of this. So if card is not null, then card.handle message. Otherwise, it was meant for the board. So now we need to declare my handle message method. And here we will just say, all right, column, handle the message. And so it's going to update its list of candidates based on that message. And then the last part of that is that when I move a card, so I am going to, in this case I'm being very explicit about creating the message inside of my test because I wanted to set up some interesting scenarios. So so we're creating our card move message with, in this case, no predecessors, and moving it to the appropriate column. So doing that, it should make this test pass. So we should be able to move a card, and that should update the list of candidates. And it does. So let me show you exactly what it's doing to verify that the test is correct. It's doing two things. There it is. Okay. So the number of candidates in my column property should be 1. There's no conflict. And that value should be to do, because I've moved it to the to do column. So you'll see there are other tests here that assert that the number of candidates should be 2, because I deliberately put it into a conflict situation. Like right here. So I changed the text to first text, and then I also changed it to second text, but neither one of these knows about the other. So I've created a conflict, and now the number of candidates should be 2. And so you'll see that if I work through and I make all of these tests pass, then I'm capturing that, that set of predecessor relationships among the facts, from there deriving the partial order and figuring out what the current state of the system is in a way that I'm showing to the user conflicts, but doing so in a consistent manner. And then all this is data bound up through the view model, projected onto the model. So now the view model says, how do you want to display that conflict? So it's the one that figures out, oh, there's a conflict, just gray out the card. And then somebody makes a change on one device, push notifications, happens on the other device, shows up to the user. Three-way data binding. Okay, so just to wrap things up, there are a couple of systems. So we walked through how to build a historical modeling system yourself. But there are a couple of systems out there that already do this for you. If you are working in JavaScript, check out Firebase. This is a really cool. I would say that that Firebase is, well, it works really well with Angular. So it isn't an application framework in and of itself, but it's a really cool way of bringing data into the browser and then doing three-way data binding against it. So Angular is doing the data binding, but Firebase is synchronizing that data among other Firebase users. So two people can bring up the browser and make changes, and they'll synchronize the changes. Yeah, so for offline activities, so far Firebase is really still for online. I haven't seen one that's really good for offline JavaScript, but Correspondence is my framework for implementing this pattern in a way that you can use offline in a mobile application, and it's done in C#. So so this works for universal applications as well as Xamarin applications. So you can use this with iOS and Android.
Okay.
Oh, okay.
When you say mobile, you mean all mobile, not web.
Yes. I mean all mobile. But that is the caveat with Xamarin. Yeah. So did you have one more question?
For each of these for like what socket
Firebase is using WebSockets with fallback, so it's very similar to SignalR in that regard. Correspondence is using HTTP for sending and receiving the messages, and then it's using push notifications for the real time, since it's running on a rich mobile platform that has push notifications. Yeah.
Can you application using in the MVC just VM like those kind of applications?
So as in.
Can your application using the MVC like MVC but more like VM?
Yeah. So. Yeah. So the MVC means a couple of different things. If you're talking MVC as in ASP.NET MVC, then there you're really talking about server rendered HTML.
Yeah, but also we have model, but also view model, two different.
Yeah. If you're
it's still going to be a kind of mobile application.
Yeah. So the examples that I showed are really more for a rich mobile application. Yeah, not so much for an MVC application. But if you wanted to do a single page application in JavaScript, then similar patterns, but then you would be using Firebase to do all that work. Yes, sir.
With Firebase right now, as it is now, how does it handle cases where you have one device online making changes, and then you had another device that made changes, but it goes offline, continues to make changes? When that other device comes online, how does it handle the conflicts?
So Firebase first of all, it doesn't have any local storage, at least last time I looked at it. So if it's offline and then comes back online, it has to be within that one browser session for those changes to persist. But then if that does happen, then Firebase does have some conflict resolution directives that you can give it, where you can tell it what strategy to use.
So would it be ideal for scenarios where you have devices that have local storage for maybe some type of settings, and maybe some users go offline sometimes, and then eventually they come back online, but the local settings keep catch of whatever changes they made, and then once it comes online, it fires to change the latest changes back to Firebase?
So typically this pattern would not be so much for settings because there are easier ways to do that.
Settings is just an example.
Yeah.
But it could be anything.
Yeah. Yeah, it's if it's collaborative data, if you've got more than one user who's interested in that data, then it becomes really important to use these patterns for that. And yeah, that's what Firebase and Correspondence are designed to do. Yeah. Yeah. But yeah, if you're just doing settings, then put them into the roaming storage and we're good there. All right. That is all I've got with that. If you want to get access to this slide deck, you can get that bit.ly/3-way data binding. Follow me on Twitter, Michael L. Perry. Remember the middle initial L. And the last couple of tweets that I did last night were that bit.ly link and the link to the source code, which you can get on GitHub. And you can also find more information about the Assisticant library, assisticant.net, and the Correspondence library at correspondencecloud.com. And I blog at QEDcode.com, and please feel free to tweet or email me at michaelperry.net, just to make it nice and simple. Okay. Thank you very much. Yes, and thank you for your